Hello everyone, welcome back to another video. Today we'll be doing a practice test on Khan Academy of AP Physics 1 Kinematics unit. And I just want to apologize for not uploading lately. I did have some technical issues with my recording device, but now we have that sorted out. So we'll be going back to our consistent uploads. And I apologize for any videos that had any incorrect answers. I'm currently working on that to update it and make sure that that issue does not occur anymore. So with that being said, let us continue with the video. So question 1 says, a time t equals 0, a soccer ball is kicked in the positive x direction at an angle above the horizontal. Initially, the ball behaves as a projectile with negligible air resistance. So far what we know is that this is a soccer ball and it's kicked in the positive x direction at an angle. So we know that this is a projectile motion question. So we can go over here and we can draw our projectile motion. So we know right here at t equals 0, so we can say this is 0 seconds. The ball was kicked at an angle right here of theta. That's the angle. And it was kicked like this. So this is what the motion is going to look like. And this right here is t final. With that being known, we can go ahead and continue reading the question. At time t1, while the ball is in the air, a gust of wind blows in the negative x direction. This causes the ball to briefly accelerate in the negative x direction. So what this part is saying, so I'll do that here and this here. This part is saying as the ball is traveling in the positive, because we know this is positive, this is positive, this is negative, and this is negative. As the ball is traveling in the positive x direction, there's a gust of wind. So let me make this difficult. There's a gust of wind acting on it in the negative x direction. And it says this causes the ball to briefly accelerate in the negative x direction. So that means the ball is going this way, right? It's going through the trajectory right here of the parabola that we know of. And while it's going that way, this gust of wind causes it to decelerate and go accelerates in the negative direction. So it causes velocity to be negative. So it starts to slow down. And then here it says at time t2, the gust has passed. The ball is still moving in the positive x direction and can again be modeled as a projectile with negligible air resistance. So now this part of the question right here, this part, let me do a better color. This part of the question tells us that the ball is still moving in the positive x direction. So that means this negative gust of wind, the gust of wind that was in the negative direction, sorry if it's off a frame, that negative gust didn't cause it to go in the negative direction, but all it did is cause its velocity to decrease. That's the main thing it did. So knowing that, we know that the ball is still going to be going in the positive x direction, just this time it's going to be a little slower than it was originally, but it's going to continue gaining that velocity. So the question asks us now, which of the following graphs best represents the ball's horizontal Vx as a function of time? So one thing I want you guys to remember, because if we look at the answer choices, here we have two answer choices. We have 4. A is saying that it was increasing, which is true. And this is at time t1, it decreased, and at time 2, it increased again. Here at time 1, it says it continued to be constant, then it decreased, and then continued to be constant at the decreased value. C is saying that it increased, and then it continued to increase, and then leveled off. And D says that it was constant, increased, and constant. So one thing I would say is that we can definitely cross out option D and option C, because here we know that this causes the ball to accelerate in the negative x direction. That means no matter what, the velocity has to decrease because it went to the negative. So we can automatically cross out C and D, leaving us with choice A or B. So now what's going to make us understand which answer choice is correct is we need to remember one thing about projectile motion. When an object is in projectile motion, when an object is in projectile motion, it has one force acting on it, and that's force gravity. The force of gravity is what's pulling down on the ball while it's traveling. And as the ball goes through its trajectory of the arc of the parabola, as it goes through it, the ball's x velocity is constant the whole time. The x velocity is not affected. The reason being, the force of gravity is only in the y direction. So here's the x and here's the y. It's only in the x direction. It's only in the y direction, sorry. It's only in the y direction, meaning that it affects only the y velocity. So as the ball is going up, here, the velocity of the y, as it goes, it decreases. But the velocity of the x just stays constant the whole time. And since we know that the velocity of the x stays constant the whole time, we can clearly see that B would be our correct choice, because B has a constant velocity here. The negative right here, the gust of wind in the negative x direction causes it to decrease, but then it stays as a constant. This is saying the velocity in the y, it increases, gets to the peak, down, and continues to increase. So that would leave us with the correct challenge of B being the correct answer. Okay, moving on to question 2. The graph below shows velocity as a function of time for two marbles, A and B, rolling across the table. Which statement about these two objects system is correct? So without looking at the answer choices, we can't really answer the question. But before we do that, let's go ahead and identify some stuff about this graph. So first of all, we can tell that this is a velocity versus time graph. And knowing that's a velocity versus time graph, we know that the slope of the graph is going to be acceleration. And then the displacement, so the area under the curve, the area under the curve is the displacement. That's what I was trying to say. The area under the curve is the displacement. So with that knowledge, we can go ahead and answer the questions. So choice A says marble A and marble B have the same acceleration at 0.5 seconds. So if we go here, it's 0.2, 0.4, so 0.5 is about right here, right? And it says right here that they have the same acceleration. Well, one thing I can already tell is that they do have the same velocity at this point, right? But we did just say that velocity acceleration is the slope of the velocity line. Knowing that, if we take marble A, we can see that no matter where we take it, it's a straight line, meaning that acceleration is constant this whole time. So we can take it. So for example, let's say I want to start from 0 and I'll go to 0.2. If I go draw this line, so here we're going to go up how many? So this is up by 0.1, so 0.1, 0.2, 0.3, 0.4. So we go up, so up 0.4, 0.4, and then we go to the right 1, 2. Oh, we go up to the right 0.2. So we go right 0.2. And we can do the same thing for the marble B. So if we just draw this line from 0.2 here, and we can draw this. Okay, sorry. That is actually 0.4. Sorry about that. That is 0.4. So we know that. Let me do this in a different color. And we know marble B goes down 0.4, and it goes to the right 0.2. And if you remember, the equation for slope is y2 minus y1 over x2 minus x1. Or we know as rise over run. So rise over run, right? With that knowledge, we can go ahead and find the acceleration for both of these lines. So for marble B, it's going to be negative 0.4 over 0.2. And then for marble A, it's going to be 0.4 over 0.2. So we could simplify these, but just looking at these two fractions, we can tell that they do have the same numbers, so 0.4 over 0.2, 0.4 over 0.2, but the direction is different. This one is positive, and this one is negative. So since this is negative and this one is positive, we can automatically say that these are not the same. And choice A is asking marble A and B have the same acceleration at 0.5 seconds. Well, the acceleration is the same throughout the whole line since it's a constant straight line for both of them. But since this one is a positive and this is a negative, they are not the same. So that makes sure that choice A is not an answer choice. Choice B says the magnitude of the acceleration on marble A is larger than the magnitude of the acceleration on marble B. Well, we did just say that marble A is 0.4 over 0.2 positive, and then we did just say that the acceleration of marble B is 0.4 over 0.2 negative. So taking the magnitude would just be taking the absolute value of both of these, and that would just give us 0.4 over 0.2 and 0.4 over 0.2. But these are equal to each other, so they're not greater than one another, so that makes choice B also incorrect. Choice C says marble A and marble B are at the same point at t equals 0.5. So if we look here, t is equal to 0.5, we can check that here they do have the same velocity, but we need to know if they're at the same position. And to do that, you might be wondering how we're going to find the position. Earlier I said the area under a velocity versus time graph is displacement. So here what we're going to do is we're going to find the displacement of both graphs. So right here we're going to find the area under the curve for marble A. So we're going to go draw a triangle like this, and we know this is 0.5, so the triangle is 0.5, and it goes up 1, so it's 1. So the area of a triangle, if you guys do remember, is base times height divided by 2. So in this case it would be base 0.5 times height is 1 divided by 2, so that'd be 0.5 over 2, which is just 0.25 meters. So that's how far it traveled, 0.25 meters. And then if we do the same thing for marble B, we can see that at 0.5 right here, we would just make the area under marble B's curve, and notice how marble B has the line way up higher here at velocity equals 2 seconds. So it starts off with the initial velocity of 2 meters per second. Starts off with the initial velocity of 2. So that means that it's going to have a greater displacement because it's traveling faster in the beginning compared to marble A, where it just starts from 0. So calculating the area under the curve, we would have to make two shapes here. We would go ahead, draw up to the line 1. We would go ahead and make a square here. So you make a rectangle first, 0.5 by 1, and then you'd make a triangle up here by 1, since this is 1 to 2 is 1, with 0.5 as its base. So combining the areas, you do base times height divided by 2 for the triangle, plus base times height for the rectangle. And solving that, you would get 1 times 0.5 divided by 2 plus 1 times 0.5. Adding these together, you get 0.25 plus 0.5, giving you 0.75 meters delta x. So now that we have our two displacements, we can tell that marble B, so here we have marble A, and then over here we have marble B. Marble B has a greater displacement compared to marble A, and to remind you guys, displacement is the distance from the origin of the start. So let's see, this is the path they're going on. So this is t equals 0, right? So this is where they start. Marble A has only traveled a displacement of 0.25 meters. So marble A has only gone this much, 0.25 meters, right? And we have marble B, who has traveled right here, 0.75 meters. And if we think about this, question C is asking marble A and B are at the same point at time equals 0.5 seconds. Well, that is just not true at all. Because here we can see that marble B has traveled 0.75 meters from where they started, and choice A has started, not choice A, marble A has traveled 0.25 meters from the beginning, telling us that 0.5 meters is way greater than 0.25. Since we know that they are not the same place. Since we know that 0.5 meters is greater than 0.25 meters, that means that marble B traveled a greater distance than marble A from the origin, meaning that they did not meet at the same point at t equals 0.5 seconds. With that being said, we know that choice C is not our choice. And then finally, choice D says during the first 0.5 seconds marble B travels farther than marble A. And going off what we said earlier, how marble B is displacement was 0.5 meters, 0.75 meters, and that marble A was 0.25 meters, it makes sense that choice D would be our correct answer since it has traveled a greater distance compared to marble A. Okay, question 3. A ball is kicked at an angle with an negligible air resistance as seen below. How is the magnitude of the horizontal velocity changing at point P? So I've said this many times in this channel, but when we have projectile motion, let's say the ball is up here. When we have projectile motion, the only thing acting down on it is force gravity. And since we know that force gravity is the only thing acting on it, and this is in the vertical, so that'd be in the y-axis, there's no forces acting in the x. So remembering that there's no forces in the x, that means there's nothing causing the x velocity to slow down. And we know that here we have the y and x, right? Sorry for horrible drawing, but we have the x and the y, right? We know that since this is the x, this is horizontal, and we know that this is y, the vertical, the only thing that should be affecting the horizontal axis is force gravity. But there's nothing affecting the x-axis. So as we said in the earlier problems, that the horizontal velocity is always constant no matter what. It's not going to change. Unless there's some force acting on it, like question 1 where a negative x direction gust of wind was acting on it, it's not going to change. It's going to be constant. And even if a force acts on it, if it acts on it for momentarily and then stops acting on it, the velocity, as we saw, is going to be constant, decrease, constant. Or it's going to be constant, increase, constant. It doesn't have to be changing. Unless it's a continuous acting force, just like force gravity, it's going to be like these two equations. And if it is a constant force acting on the x direction, it's going to be like the y velocity, increasing, decreasing. With that being said, I think that it's very straightforward with the answer choices. It says, how is the magnitude of the horizontal velocity changing at point P? At point P, we know that the horizontal velocity will not be changing no matter what. So we can cross out increasing, we can cross out decreasing, and we can cross out non-information. And we can just choose answer choice D, not changing. Okay, question 4 says, a rock climber moves 2 meters to her right and then climbs 4 meters up the side of a cliff. How many degrees above the horizontal is the climber compared to her initial position? Assume rightward is a positive x direction and upward is a positive y direction. So what I would do in this situation is just draw my axis. So here we know that this is the y and this will be the x. Okay. So it says that positive, the rightward is positive. So positive x is rightward and positive y is upward. So now that we know that information, we can go back to take our information one by one. So a rocker moves 2 meters to her right. So let's say this is the position graph. So this is y, y is position, and x is t. Okay. And a rock climber moves 2 meters to her right. So now that we have our axes, now that we have our y and x axis, we can go back to the problem and take the certain information we need. So let's make this, let's just make this our positions. So a rock climber moves 2 meters to her right and then climbs 4 meters up the side of a cliff. So right here we have 2 meters to the right and then it goes up 4 meters up. So let's say 2 meters and this goes up 4 meters. How many degrees above the horizontal is the climber compared to her initial position? So you might be wondering, what can we do with this information? So now that we have an x, so this is our x component, and we have our y component, we can make a vector here. With that knowledge, we can go ahead and create this and make a line. And how would you find a vector is just pretty simple. If you notice, I know that this isn't a straight line, but if you notice, this right here creates a 90-degree angle. And with a 90-degree angle, we can use the Pythagorean theorem to find the hypotenuse right here of our c value. So with our equation, we can do a squared plus b squared equals c squared. And plugging in our values, a can be 2 squared plus b can be 4 squared, and c squared is what we're solving for. We can just take the square root of this, square root, and we have the square root of 2 squared is 4, plus 4 squared is 16, equals c, and the square root of 4 plus 6 is 20, so the square root of 20 equals c. And knowing that c is 20, we can square root of 20, we can have our triangle. We can have 2, 4, and square root of 20. And then it's asking us how many degrees above the horizontal is the climber compared to our initial position. So it's saying how many degrees above the horizontal. So the horizontal would be the x, so we're going to create our angle between the x and the vertical. And it wants us to find what is this value. To find this angle, we could use sine, which is opposite over hypotenuse, or we could use cosine, which is adjacent over hypotenuse, or we could have just avoided this whole process over here and just used tangent, where we did opposite over adjacent. And no matter which way you do it, you'll get the same answer. So then once you plug that into your calculator, you should get a value. And as I said, you can use any way you'd like. So if you want, you could do arc sine. So arc sine is just inverse sine of 4 over square root 20. You could do arc cosine of 2 over root 20. Or if you wanted to skip all this work to find the hypotenuse, as I said, you could just do arc. Here, let me write this up here. You could just do arc tangent of. So arc tangent is opposite over adjacent, so just y over x. So then you could have just done arc 4 over 2, and that would have given you all the same answer of b of 63 degrees. Question 5 says, a water balloon is thrown down from a window with a speed of 2 meters per second and lands on the ground 5 meters below. Assume air resistance is negligible. What is the final velocity of the ball just before hitting the ground? So with this being said, we can go ahead and draw a diagram based off the information we know. So what we know so far is that the water balloon is thrown down from a window with a speed of 2 meters per second. So we know that this has an initial velocity. So if we make our axis going upwards positive y and going to the right positive x, the water balloon being thrown down means that this is a negative velocity, and it's a negative initial velocity of 2 meters per second. And you might be wondering, well, is this going to the x or in the y, since we have to split it into our xy components? Since it tells us that it is thrown down and doesn't give us a degree, saying like at an angle of 35, we know that this initial velocity is all in the y direction. So knowing that, we can just put our variable, because we have our equations here ready to help us whenever we need them. We can just put in our equation v0y, so v initial y is equal to negative 2 meters per second. Continue reading the question. We can see that it says, and lands on the ground 5 meters below. And since it's saying 5 meters below, we know that this height, so if we drew this window, so let's say this is the window right here, that it says from on the ground 5 meters below, the ground to the window is a distance of 5 meters in the y direction. Okay, so we know that displacement in the y is equal to 5 meters. Now we're asked, what is the final velocity of the ball just before hitting the ground? So we're trying to find v final, and since we have all the y direction stuff, I would like to find the v final in the y direction. So it's asking us now to find the final velocity, right? So we're saying, what is it here? Meters per second. Now, we have to remember that in the y direction, so while the ball is going downwards, there's a force acting on it called force gravity, which I'm sure you guys know. So we have force gravity acting on it. So since we have force gravity acting on a downwards direction, we have to incorporate it here. So that would be our acceleration, because later on we'll learn in Unit 2, force equals mass times acceleration. And our force is equal to force gravity, so that's our acceleration, which would be 9.8 meters per second squared, which is our gravity. So now that we have all this information, we can go ahead and try to find an equation that gives us final velocity without making us use time, since we're not giving time a single time. We're not giving time at all in this question. So this equation has time, so I wouldn't recommend using it. This one also uses time, so I wouldn't recommend using it. This one doesn't use any time, And this is our last option, so luckily this one is the right answer. So knowing that, we can go ahead and write our equation, which is v squared is equal to v initial squared plus 2a times this x minus x initial is the same as delta x. So then we will say delta, and in this case, since we're solving with the y direction, this would be delta y, acceleration in the y, velocity in the y, v final in the y. So v final and this acceleration in the y. Knowing that, we can plug in all our values. We have our acceleration, we have our v final, we have our delta y, and then we have our v initial. So we can plug everything into this equation. Okay, now that we've plugged everything in, we get our new equation over here of v final y squared is equal to negative 2 squared plus 2 times 9.8 times by negative 5. And if this did just turn to negative 5, I forgot to mention that since this is the displacement, it travels from the origin 5 meters downwards. Since we said that the y is negative, downwards is negative, upwards is positive. So this would be negative 5 as a displacement. Knowing that, we can go ahead and solve. So negative 2 squared would be 4 plus 5 times 9.8 would be negative 49 because negative 5. And then negative 49 times 2 would be negative 98. So plus negative 98 is equal to VFY squared. And then VFY squared is equal to the square root of, to get rid of the square, we do the square root of 4 plus negative 98. So we get VFY is equal to the square root of negative 94. And you may be wondering, why do we have a negative in the square root? Because we know that we can't have negatives in the square root. And that's because we did not pay attention to our coordinate system. We said earlier, right here, assume a coordinate system in which up is positive. We said right here, our coordinate system that we drew, this positive y direction is up, is upwards. Let me do this in different colors. So upwards is our positive, right? That means downward must be negative. And if we look, the only way to make this side positive, because this side is what's making us end off with a negative answer, the only way to do that is to make this negative cancel out. And to make that negative cancel out, we have to multiply by a negative number. And we can't multiply by negative 2 because 2 is just a constant in the equation. What we have to multiply by is a negative 9.8. And you might be wondering, why would we make negative 9.8? See, over here, you might be thinking, yeah, gravity is 9.8. It's positive, so we should just take it as it is since it's our acceleration. But, as I said earlier, force gravity over here, the force gravity is acting in the downwards. And what did we say? We said that upwards is positive and downwards is negative. So that means this gravity, or our acceleration, so our acceleration is equal to gravity, but a negative gravity, since it's pulling it downwards. Just like we said with the delta y, it's negative because it's going downwards. So now, if we plug in negative here, we would get positive 98. Then 4 plus 98 gives us 102. And taking the square root of 102 gives us v final y is equal to 10.1. And as it says right here, round your answer to 2 significant digits, so we can just round it to 10 meters per second squared. But we do have to remember one more thing. As we said, up is positive, right? Up is positive. I'm going to say that many times. So that means that the velocity has to be negative 10 actually, because it's going in the downwards direction. The velocity is not ending off on the floor going upwards. It's ending on the floor going downwards right before it pops. So that means the answer would be negative 10. Alright, question 6. A batter hits a baseball at an angle theta above the horizontal. The ball leaves the bat at a speed v1. The ball is caught by another player at a horizontal distance d from where it was hit. So right here we have the model, and then it says the batter hits a second ball at the same angle as the first, and this time the ball is caught a horizontal distance 3d from where it was hit, as modeled below. So here we can see it's the same theta, but it's a different velocity and it's a greater distance. What speed v2 of the second ball as it leaves the bat? So we're asking what is the speed as it leaves the second bat. So I'm pretty sure I mentioned this in my Unit 1 Kinematics review slideshow, but when we have something that is hit at an angle or shot at an angle like this projectile motion, this exact scenario, we can use something called the range equation, if you remember. So the range equation, which I'm going to put up right now. So the range equation, I decided to turn up the transparency by the way, but the range equation is v squared sine of 2 theta over g. So you might be wondering, what can we do with this information? So what we're going to do now is we're going to set these two equations equal to each other, plugging in the corresponding correct values. So for up here, we would plug in the range, or the range is just d, by the way, so you can replace r for d, which is just the same because range is distance in the x, so you can just replace it for d. So we'd say for this choice it would be d is equal to v1 squared sine 2 theta all over g. And then for this diagram we would do 3d is equal to v2 squared sine 2 theta over g. And basically what these answer choices are wanting us to do is just compare v2 and v1 to each other and seeing how are they equal. So one way we can do this is just setting them equal to each other, and to do that we have to get them equal to the same variable. So in this case the easiest thing we'll do is to set them equal to d, since they both have d, and the only thing we need to do is to just divide by 3. So this would cancel out, and then that dividing by 3 would just add on a 3 down here, so giving us our new equation as d is equal to v2 squared over sine of 2 theta over 3g. Now that these two are both equal to d, we can now set them both equal to each other. Okay, now that we have these two equations equal to each other, one thing we can do is just cancel out the same things that they have, because we know they're going to cancel out. So sine 2 theta can cancel out with this sine 2 theta, and this gravity can also cancel out with this gravity. Now after we do that, we're left with v1 squared and v2 squared over 3. And now to get v2 squared all by itself, because it's asking us what is the speed of v2, to get v2 all by itself, all we have to do here now is just multiply by 3 to get this away, multiply by 3, and then to get rid of the square we would do taking the square root of this, and taking the square root of that would give us square root of 3, and since this square can cancel out, this is the same as just taking the square root of each. Square root of 3 times v1. And if we look at our answer choices, the one closest to our answer choice would be choice B, square root of 3 v1. And I know I did that pretty fast, so if you guys didn't understand it, I'd advise you guys to go through the problem and repeat the video one more time. And if not, please comment down below and I can make a separate video just going over the range equation. Okay, question 7. A zoologist collects velocity and the position data for a hippo accelerating to escape a predator. The zoologist then plots the velocity v of the hippo as a function of its time x. The resulting graph is curved, not linear. Based on the shape of the graph, the zoologist decides to square the velocity values to create a graph of velocity squared as a function of position x. The resulting graph is shown below. What is the acceleration of the hippo? Assume the hippo runs in a straight line. So we know that acceleration is equal to the slope of a velocity versus time graph, right? So velocity versus time graph. That the slope of that is acceleration. So if we had this, taking the slope of that would give us the acceleration. And here we have a velocity squared versus x meters. So since in your typical velocity versus time graph, you would use the slope to find acceleration, you would do the same thing here, but in a very different way. So notice how this is v squared and not just v, and that this is displacement and not t. Notice how right here it says that assume the hippo runs in a straight line. We are going to use the equation for a straight line, which is the slope-intercept form. So that would be y equals mx plus b. So here we have right here 20 meters per second squared. So you would say that this 20 is your b. So 20 would be plus b. And we know that our y, which is our y-axis, is v squared. So we can say that our v squared. And then we want our slope, which is mx. So we can put mx, and then x would be just our x meters plus 2. And this looks familiar because it's one of our kinematic equations that we can use. If we just scroll down here and we click our physics inference, we can find right here v squared is equal to v initial squared plus 2 times 2a, which is a is our acceleration, times our delta x. And in this case, our delta x would just be our x position because it is just going from the initial position in going on. So our delta x in this situation would just be our x. So since we know that this is our equation, we can just match this up. We can write down v squared is equal to v initial, which we said was our 20, v initial squared plus 2ax. And as I said earlier, this v initial was our 20, so this is our b, this would be our y, and this would be our x. So then our slope is just the 2a right here. 2a is just m, would just be our slope. Knowing this information, we can go ahead and find this rise over run, so the slope of this equation, and then you can use this equation right here to find the acceleration. So with that knowledge, we can go ahead and try to find the slope of here. So if we find any point that where they intersect, we can find right here is the next point right here, 5, 6, and 0, 20. So we can see that it goes up 60, or we can just use y2 minus y1 over x2 minus x1 to make this much more simpler. So y2 is 60, y1 is 20, x2 is 5, and x1 is 0. 60 minus 20 is equal to 40. 5 minus 0 is 5. And then 40 divided by 0 is 8. And remember what we said earlier. We said that mx, our slope right here, is going to be 2a because our x value right here, this is the same as y equals b plus mx. So our m is corresponding to 2a. Knowing that, we can just plug in our value. What we found was a is our m, our slope, right? We can go ahead and solve that and just plug in 8 is equal to m, as we said up here. 8 is equal to m, and then 8 is equal to 2a, and then just divide it by 2 to get a by itself, and we find that a is equal to 4 meters per second squared. Okay, question 8. Velocity vector VA has a magnitude of 2 meters per second and points right. Velocity vector B has a magnitude of 6 meters per second and points left. Which of the following accurately represents of these two vectors? Which of the following are accurate representations of these vectors? And it says choose all the answers that apply. And it assume a coordinate system where left is negative and right is positive. So we need to remember that this way is right is positive and left is negative x. So it says velocity vector A has a magnitude. So let's just say this is the origin. Velocity vector A has a magnitude of 2 meters per second, points to the right. So we can say this way is velocity vector A. And it says velocity B has a magnitude of 6 meters per second and points left. So we can say it points this way, and let's say this is velocity vector B. And so this is how they would look with each other. And since we want to see how they look, we can go by the point values. We can go like 1, 1, and then 1, 2, 3, 4, 5, 6, right? So this would be 1, 2, this would be 1, 2, 3. Or another way we can do it is by using these little boxes. And if we say that each box represents 1, or it has to be a constant value, then we can find the correct value of the correct magnitude of the vector. So here we said VA is equal to 2. So if VA equals 2, and one of these boxes is VA, that means each tick mark or each box has to be 2 long. But we can already see with VB that this would be 2, 4, 6, meaning that this could work as our choice. Here we have VA has it going to the right, 1, 2, and here we can see VB goes to the left, 1, 2, 3, 4. But VB has to be going to the left 6 meters per second, and this is only going 4. And we know by VA that each tick mark is represented by 1. This would be 4, and since 4 does not equal 6, we know that choice B would not work. Now going on to VA, choice C says VA is equal to 2 meters per second and VB is equal to negative 6 meters per second. This is true because based off our coordinate system where left is negative x and right is positive x, this one works. So choice C does work. And then choice D just has no direction, and that's not true because a vector must have both direction and magnitude. Because if it only has magnitude, then that is scalar, and a vector needs both. So that leaves us with our 2 correct choices of choice A and choice C. A drone drops a package on a target from a height of 2.4 meters. The drone is traveling horizontal at a speed of 1.5 meters per second. We can ignore air resistance. What is the horizontal displacement of the package during the drop? So here we have our y-axis, and then we have our x-axis. And here they were nice enough to draw already for us our positive y and positive x. So now we can go ahead and just write what we're given. So it says a drone packet on a target from a height of 2.4 meters. So I'm going to actually write the x down here because this is what we're actually looking for. So we know that the height is 2.40 meters and the drone is traveling horizontally at a speed of 1.50 meters per second. So we know that Vx is equal to 1.50 meters per second. Now we're asked what is the horizontal displacement of the package during the drop. And to know that, we're going to look at the equations we're given in our reference sheet. And in the reference sheet, we're giving that here we can see that displacement is equal to initial position plus v initial squared plus 1 over 2 at squared. And we know that since gravity is only acting in the y direction, there's going to be no acceleration acting in the x. So we know that our equation is dependent on v0 times v initial in the x. So Vx is 1.50 meters per second times t. We're going to have to use the same exact equation, but this time in the y direction to find our time, since we have our acceleration of gravity. Okay, now that we have this equation, we know that our initial position in the y is, so this should be y0, sorry, this is 0. Our vy, we know that there's no initial velocity in the the vertical, so this can cancel out. So we're left with 1 over 2 at squared. So we know that 1 over 2 at squared is equal to delta y, and we know that it's negative since the positive y is the positive direction, so this going downwards is negative 2.40 is equal to 1 over 2 a, which is our acceleration, is going to be negative 9.8. As we said earlier, the acceleration is going to be acting downwards on the package as it comes, so it's going to be negative 9.8 meters per second squared times t squared. So getting t by itself, you'd multiply this by 2, this would cancel out, and divide by negative 9.8. Doing that would giving us 0.49 seconds, but don't forget this is t squared, meaning we have to take the square root, taking the square root, then taking the square root of 0.49 gives us the answer of t is equal to 0.7 seconds. Now, the next step is to take this time that we got and just plug it into this exact same equation, but now for the x. So plugging in our equation, we have delta x is equal to x initial plus v initial in the x, t plus 1 over 2 at squared in the x. And since we said that the force gravity is only acting in the y direction, there's going to be no acceleration in the x. so that means this can be canceled out because this is going to be 0. We have no initial position, so this can also be 0, giving us delta x is equal to v initial on the x times t. Then plugging in our no values, delta x is equal to 1.5 times 1.50 times by 0.7, giving us that delta x is equal to 1.05 meters. Okay, question 10. Question 10 says, a bird is flying back and forth. Its velocity v as a function of time t is given in the graph below, where rightwards is the positive velocity direction. What is the bird's displacement, so delta x, from time equals 2 seconds to 4 seconds? So we know that a velocity versus time graph, displacement is just the area under the curve. So it says from time t to 4. So if we go from here, time t seconds to 4 would be right here. We would go ahead and just draw a hard line right here at 4 seconds and just calculate the area from this portion right here, since this is area under the curve. And remember, since this is negative, this is in the negative axis, whatever answer we get, it is going to be a negative because we have our negative y-axis multiplied by a positive x-axis. So looking at this, you might be saying that this is odd shape. You've never learned how to calculate an area for this. If you're saying that, you can go ahead and just separate this into two different shapes. So right now we have a triangle, and the triangle's x-axis is by 1, and then its y-axis is by -5. And remember, the area of a triangle is base times height divided by 2. So this would just be 1 times -5 divided by 2, which would be -2.5. Now we're left with this area, and this area would be 3 to 4, so that's just 1. And this is -5, so the y-axis is -5, and this is a rectangle. And the area of a rectangle is going to be base times height. Sorry, not base times height. Length times width, and that's going to be 1 times -5, giving us -5. And since this is a displacement, we can just add them up together. So -2.5 plus -5 gives us -7.5 as our final answer. Okay, question 11. A cyclist accelerates from rest to velocity of 8 meters per second over 23 seconds. What is the magnitude of the cyclist's displacement? So here are physics equations that we can use. So we see that a cyclist accelerates from rest, so we can know that v initial is equal to 0 meters per second. And we know a cyclist is going to be traveling on the floor because cyclists don't go vertically, they don't fly. So technically there's no reason to this, but to get into the habit of it, we could say v initial in the x to get in the habit of it. And it says that the time taken was t equals 23 seconds. And it's saying what is the magnitude of the cyclist's displacement. So we know that, I don't know how, sorry. And the v final in the x is equal to 8.0 meters per second. So now that we have our three variables, we can see right here that something I even almost overlooked. It says, assume the cyclist accelerates uniformly and moves in a straight line. Knowing that the cycle accelerates uniformly, we can use that acceleration as equal to the delta v over delta t. And this is going to give us our average acceleration, or in this case, our constant acceleration since it accelerates uniformly. So this would be 8 meters minus 0 over 23, giving us our acceleration. So that A is equal to 0.35 would be our meters per second squared. So if I put that over here, acceleration is equal to 0.35 meters per second squared. Now that we have our velocity initial, our time, our velocity final, and our acceleration, we can find the equation that we need to solve for displacement. So right here, this equation does not have any displacement, so there's no point in using it. This one has displacement and it has acceleration, so this is one question we could use. Or we could also use this one, which is just delta x, which is v initial t, plus 1 over 2 at squared. But I'm going to go ahead and use this one for me because for me this is easier. So right here it says So right here it says v squared. So if we use this equation, that would be plugging in our equations. That would be 8 squared is equal to 0 squared plus 2 times 0.35 times delta x. So 8 squared would be 64 is equal to 0 plus 0.35 times 2 is 0.7 delta x divided by 0.7 divided by 0.7. 64 divided by 0.7. That would be 91.43 meters as our delta x. And to check if this is correct, we can go back and plug it into the other equation over here, where delta x is equal to, so delta x is equal to v, this would be initial, initial position should be 0, v initial would be 0 times t would be 23, which is just be 0, plus 1 over 2 times 0.35 times 23 squared. So this would be 0, 0. So then delta x is equal to 0.3. So 23 squared is 529. So 0.35 times by 529 all over 2 would give us delta x is equal to 92.575. Now, you may be wondering, why do I have 91.43 meters and 92.575 meters? That is because I did not round my number pretty well. So if you notice that I had my acceleration, I had 8 divided by 23. That gave me 0.3478 in some other numbers. And I decided to just round it to the 2 decimal place, giving me 0.35. But when I plugged in 0.35 here and here, that gave me 2 different answers. This one gave me 91.43, and this gave me 92.575. They are close to each other, that is true, but if someone were to round it, this person were to round theirs to 91, and this person would have rounded theirs to 93. And 91, 3 and 91, there's a +2 gap between the two. So one thing I'm about to show you guys is how to always try to minimize this gap. What I would recommend you doing is not doing what I did. Do not round to 0.2. Do not round to 2 decimal places. Round it to 3. So here we would actually have 0.348. So let's try plugging that in. So 0.348 for 0.35, and then over here for our other 0.35. So doing that, we would get our answer choices would now change to, our answer choice for this one would change to 91.954. And over here, our answer choice would change to 92.046. Now, if we look at these 2 new choices, we can see there's a clear thing we can round it to. This would be 92.0. We could round this down to 92. And this one is 91.9, where we could round it up to 92. So that would give us the same answer of 92. So what I'm trying to say is, whenever you're given a decimal, please try to round it to 3 decimal places, because that'll give you the most accurate answer compared to others without having a greater rounding error. So that gives us our answer of 92. Okay, question 12. An object travels in the positive direction with increasing velocity. Which motion diagram could represent the motion described above? And it says, assume a coordinate system in which left is negative and right is positive. The time interval between dots is the same for all cases. So it says an object travels in the positive direction with an increasing velocity. That means that we have to make sure that all the arrows are pointing to the right, because it says right here that right is positive, so we have to make sure that all the arrows are pointed towards the right, like this. So any choices that don't have them all pointed to the right, we can automatically eliminate. So choice A has all of them in the left. Choice B is good so far. Choice C is incorrect, and choice D is correct so far. And one thing I wanted to remind you guys is that the length of a vector represents its magnitude. So if we compare vector 1 to vector 2, you can tell that vector 1 is less than vector 2. The reason being, vector 2 is way longer. Vector 2 is made up of 4 vector 1s. So that means that 4 times vector 1, so v1, is equal to v2. Would be equal to v2. That being said, we need to look and find which one has a diagram with an increasing velocity. So an increasing velocity would look like velocity vectors going from small, getting a little bigger, getting a little bigger, and getting a little bigger. If we look at choice B does exactly that. It goes from small, gets a little longer, and gets even longer. And choice D does a complete opposite of choice B. It starts off long, gets shorter. So we can cross out D, knowing that our correct choice is B for this part. Now, the second part of this question is asking us which position versus time graph could represent the motion described above. And we're asked position versus time. And if we scroll up, we selected that the velocity is going to be positive. And since the velocity is positive, that means that it is going to be traveling in the positive x direction. So we're going to have our slope going positive this way, since this is positive x, and positive y. So knowing that, we can go ahead and draw our graph. But one thing I want to remind you guys is that we have an increase in velocity. So this is going to be our position versus time graph. So an increasing velocity, where if we had a graph and our velocity was going this way, that means we have a constant velocity. So that would look something like just constant vector arrows, same magnitude, so same length. But since we have them slowly increasing, our graph is going to actually be increasing like this, Not as aggressive as this, I would say, but something similar to this. So if we go look at our answer choices, we can see which one matches up with our graph that we created over here. Choice A does not work because it is decreasing, so we can cross out choice A. Choice B looks almost like an exact copy of what we have, so we can select choice B. Choice C has it increasing and then leveling off, like it's reached its max velocity, but we don't have a max velocity here, so we can cross out choice C. And choice D has it just decreasing again, so we can cross out choice D, leaving us with choice B as our correct answer. Okay, question 13 says, a water balloon is tossed straight up at time t equals 0, and it says, which of the following graphs represents the velocity of the ball as a function of time? Assume upward is chosen as the positive direction and that the air resistance is negligible. So first thing I want to say is that since this is a velocity versus time graph, we know that the line is going to be constant. Reason being, acceleration is going to be constant in this scenario because the only thing affecting it would be gravity pushing it down. Because this is asking for the velocity, not saying velocity in the x or in the y. This is just saying overall velocity. We know that it has to be a straight line no matter what. Knowing that, here it says the water balloon is tossed up straight at time t equals 0. That means that no matter what, in the graph must have a initial velocity somewhere up here. Because the ball is straight up at time t equals 0, it should start here or anywhere, just not at the 0. So looking at our choice options, we can already cross out, I would say, C and B. Reason being, they start negative and it's tossed straight up. And here we know that upward is chosen as a positive direction, meaning that it has an positive initial velocity, meaning that our choices cannot be B or it cannot be C. So with that information, we can go ahead and go on to our next choice. So our next choice is going over, is it A or D? A is a constant straight line, like I said, since the acceleration is constant, and D is not a straight line. It goes down and then comes back up. But what we need to remember is in projectile motion, the graph, not projectile motion. This is not projectile motion. This is just throwing the balloon going up and then the balloon getting to the top and the balloon just coming back down. So let's just say that this is t equals 0. This is t equals 1. So t equals 1. T equals 2. And then t equals 3. This right here is going to be t equals 4. T equals 5. And then t equals 6. Right here, you are tossing the ball up. So this is where it starts. It starts all the way down here, and you toss the ball up, meaning that this velocity is going to be positive here, positive here, positive here, and positive here at the top. But it's going to come back down because gravity is going to pull it down, because no matter where you are, gravity is pulling it down, gravity is pulling this down, gravity is pulling it down, gravity is pulling it down, pulling it down, pulling it down, and pulling it down. Because the acceleration is constant, the gravity is constantly pulling down on the water balloon no matter where it is. Knowing that, when the water balloon comes back down, its velocity is going to start to become negative because it's going down in the negative direction. Because as we said earlier, upward is chosen as a positive direction. So as the water balloon goes up, it's going to be positive, and as the water balloon comes down, it's going to be negative. And the key difference between choice A and choice D is that D has it positive and then positive again. But we just said over here that has to be positive going up and negative coming down. And knowing that, looking at choice A, we can see that it's positive on the way up, and right here, when it flips and it starts going downwards, it's negative. And that is what we're looking for. Something that goes upwards in the positive y direction, it's positive, and something when it comes down in the negative y direction, it's negative. So that leaves us straight to our choice answer A. Okay, last but not least, question 14. And if this video was helpful for you guys in any way, please comment down below so I can know, so I can continue making these videos. I apologize if this is a long video. I thought it was a very helpful video. But with that being said, let's go on to our last question. Question 14 says, a car is driving west as it slows to a stop at a red light. An acceleration versus time graph of a car's motion is shown below. Which velocity versus time graph correctly represents the car motion? So with this being said, we have to remember the correlations between all our graphs. So this is an acceleration versus time graph. And the acceleration versus time graph is the slope for the velocity versus time graph. So here, if we have our velocity, if we have our velocity versus time graph here, we know that since this is a constant value, the acceleration is constant. No matter if it feels like this, like this, like this, like this, these are all straight lines. It's constant. If the acceleration was looking like this, then our graph would not have a constant slope. But since it's just a straight line and it's positive, that means our velocity versus time graph is going to be increasing constantly. So it's going to be a straight line like this. And since we know that a car is already driving, it's going to have an initial velocity. So it's going to look something like this, because it has our initial velocity when we started driving, and it has a constant slope of 2 meters per second squared. And with that being said, we can go ahead and look at which answer choice matches up the graph that we have. Choice A has it going down. Automatically, we can choose that as incorrect, because we know that this is a positive value 2. And since it's a positive 2 value, we know that choice A is not going to fit that since it's decreasing. So we can cross out choice A. Now choice B says the velocity graph is going to be increasing, which is true, but we already know that the graph is driving west. And since it's already driving west, that means it needs to have at least some initial velocity. And since choice B starts at 0, we know that choice B is also incorrect. If we look at choice C has a positive slope, and it also has an initial velocity. And here we didn't specify if driving west or east was positive or negative. So that means C is also a viable choice since it has our positive slope. So let's look at the other choices. Choice D has a negative slope, and we know that our acceleration is positive, so that means it needs to be going in the positive direction. So that leaves us with choice C being our correct answer. And I know that this negative 20 might throw you off since it's not as similar as our graph. But remember, if we say that east is positive and west is negative, if if it's already going negative 20 meters per second in the negative direction, then we add our positive, it's totally fine to have a negative v velocity, because we can remember that it says it's going to stop at a red light. And if you're adding a positive acceleration to something that is slowing down, if that velocity was positive initially and you add a positive acceleration, it's just going to continue to speed up. But if you add a positive acceleration to a negative value, a negative initial velocity, it's going to slow down, because that negative is going to be canceled out by this positive. So that's why choice C would be our correct answer, because although it has a negative velocity, that is not wrong, because for this object to slow down at a red light, we're going to need to add a positive acceleration, because remember, a vector, positive, negative, is just the direction, and we need it to oppose the direction of the initial velocity, leaving us with choice C as our correct answer. With that being said, guys, I hope you guys really enjoyed the video. If you guys did, please like the video, subscribe if you haven't already. I will be continuing making these practice tests. I hope the next one can come out in a couple of days, and I will continue making those daily problems. As I said, the technology issue has been covered now. And I just wanted to end off with just a quote to motivate you guys. It says that everything is theoretically impossible until it's done, by Robert A. Heinlein. So this is just a quote that I think is very helpful. So if you guys have any big dreams that you guys want to achieve, please don't stop. Just keep going, because nobody might believe in you now, but at the end, when you finally do it, you will have many supporters believing you, saying they did. Even though they didn't, you know that you showed everyone that the impossible is actually possible. Because if you remember, guys, impossible says I'm possible. So with that being said, I hope you guys have a good day, continue your prepping, and remember that life is to be enjoyed.